Okay, so let's continue. Right. I want to profile this line a little bit, this function. So let's try to go for Python 3.8-10.12-9-b. It's rating a lot here in Singapore. Okay, so that's no. I only want to run one, so let's remove this. I'm not interested in the other stuff. Okay, anyway, this is the profile. Okay, so after running the profiling, we have some like almost 70% spent here, and then 20% spent here. There's not too much optimization set, except okay, maybe here 4%, and then things like that. Profile this instead. 4% well, that's non-trivial. But recall that this .add operation. I mean, you can choose to stop here, but if you want to take it a little bit further, then you know that this is not a very efficient operation, particularly when it was in a double for loop. But even inside a single for loop, it doesn't suddenly become more efficient. So, for example, you can see that any operation with this, .add, is still going to take some significant amount of time, right? So, for example, this .add operations, if you sum all of them up together, it takes up about 60% of the time. Inside this particular get-test function, which takes about 5% of the time, and then all of these operations take up about 1% each. We can actually, in fact, remove them to almost close to zero. And to do that, we're just going to, we're going to try to remove all of the .add operations, so the nominal total, leverage, things like that. We want to completely remove. So leverage, capital, P&L, nominal return, capital return. So okay, so for all of the, basically for all of the, suppose things we're keeping track, all the variables or states that we're keeping track inside this data frame, we are going to only create it at the end of the entire simulation. So for example, here we can do capitals, we can do wages, P&Ls, nominal widths, and capital widths equals 2. And then how many is this? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here there's noise. Right. Inside here too, I mean. Okay. So now we're going to use this array here instead to keep track of the positions of the other meta variables. Instead of keeping it and assigning it and building up the data frame, we're going to maintain that inside a Python list instead. All right. So, okay. So look at this portfolio data frame. So instead of returning this particular thing, we're going to say, okay, we're going to return $10,000, 0.0, 0.0. Nope, this thing here. And then we're going to return this thing and comment this out. And so in the portfolio settings, instead, we're going to get capital, P&L, capital return, okay, and we set all of this to 0, and then we set current condition is capital, P&L to 0, capital return to 0, okay, capital for the wages, P&L, nominal returns, 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5, there we go, one of that, and return. Okay, so this is how I'm going to assign that. Let's smooth this out. Okay. Remember, this variable is just helping us to keep track of the thing inside the backtest simulation. We're not trying to change any of the logic. We're trying to keep the logic exactly the same, and then move on. Just so that we can sort of. Okay, let's put that here. So inside this, where we're passing the profile with everything. Let's look at dot add. So get PNL stats. You're getting data information about the previous average. Right, so let's just pass in the things like the average this information. Right, and then instead of having that, we can just return the last operation. We can just return the last one. Right. Let's just return this number return and the count return. In order to get the PNL, we actually don't need to do all of those computations. All we need to do is just count return. We can just remove this. Return equals to return. We can delete these lines, right? And then actually we're not using this two things anymore because we got rid of this portfolio DF and portfolio I. We don't actually need to use these two things anymore, so let's remove that. And then let's go to that. We don't need this anymore. We can replace this with collaborators, and then we have this over here. Okay. Where else do we need to keep track of variables? Well, now we also need to add this. So here we have we're returning the normal return and the counter return. So here we have normal return. Right, so let's set the capitals. Can we do that? The capitals equals to capitals to 10. Second capitals negative 1 plus PNL. That makes sense. And then we have the normal return, and the counter returns, and the capture return. So that's fantastic. Do we need anything else here? I don't think so. I think everything here is fine. And then we have to go to the last statement here, where we don't want to get rid of this dot add assignment verb statement. So we do normal. Okay, we want to keep track of these two. So DP notes. We don't need that. No, this one's empty in the beginning. Do we need to keep a track of PNLs? I don't think so. We do nominals and total averages average. So this should no total capitals. That's one capital we have. So I think this pretty much removes all of the dot add statements that we had. Right. So let's see whether this is accurate. We're trying it. So instead of having this dot add statements, we can do it. We can maintain the state using an array. So okay, let's see if everything here is correct now. Right. So another return, counter return. We don't need to make it so complicated. Let's just put 0 here and 0. So we can just return. We don't need, okay, let's just get rid of this completely. $10,000, 0, this is the float. Okay. So let's load it here. So these are the things that needs to be pre-initialized. And then this one will be updated inside of the for loop from the first iteration onwards. So think everything else should kind of work. Some capitals and pens, this is the previous day. So everything that goes inside this loop, right, it starts with some value initialized. Everything that kind of gets initialized. Right, see, so this already initialized with some values, and then this thing that gets initialized without any value inside the array is kind of updated outside. Outside the if condition, right? Then their respective lengths will be the same. Just make sure that statement is true. So nominal is here, averages is outside the if loop. Total. It's held. That's outside the if condition. It's over here. If everything else is kind of inside the if loop, just capital, nominal, capital returns, UMOs and ustrings. Kind of gets done. I don't know why we self here. Let's make this easier. Let me self assignments. Okay. But at the end, we still want to obtain the data frame. We still want to have the data frame returned to us. So we can do something like, what variables do we have? Whether that's kind of just copy and paste this line. Let's just keep this profile in here inside the main file. So later we can compare and see whether our optimization is indeed helpful or just wasted our time. But anyway, let's go back to that. Oops, units is an array of arrays, so we want to create a data frame of that. And it's held index equals to the date range, and columns equals to names plus units. Right. We still have some things like weights. That's a data frame. This one we will take weights held. We replace with this W. Okay, then it comes to this singular array of scalars. So this one we'll use it to create a panel series instead. The data equals to nominal. Nominals. Same thing. It's just index equals to the range. This one we'll give it a name. Column total. We have the same for strategy, leverage, and return, capital. Okay, so let's try to create nominal, leverages. There's also capitals. This nominal returns, capital returns, and last but not least. Okay, you're not. Okay, string scalars. Here. Right, is there any other information we want to maintain? So we have units, weights, we have this scalars, capital, nominal, capital returns, nominals and leverages. We don't really need that. Okay, we just need to leverage. Those with nominals and leverages. Let's try this scalars. So again, let's just try to make this a little bit more readable. Return series, stress scalar series. Okay, then let's try to do this string scalar. Capital. Okay, then let's now create a profile here. Okay. And this is equals to 1. What do we want to give here? Give it yes. It's data frame. Nominal. Next series. String scalars. Scalar series. Nominal series. Cap series. Okay. Well, okay, so just do return series and the capital just. So I think this is pretty much it. We really need to give it an index. Okay, anyway, let's see what we have over here. This should all share the same date range, so we don't need to do this, I think. Okay, let's just go ahead and see what happens inside there. So unit place dominance averages counter node. Something over here. So let's look for this statement. We don't need this anymore, so let's use this. We're not using this, right? Are we? Okay, I need to replace this with profile I and profile 1. Let me think about this for a moment. Okay, so we don't need this, but so that we need to create this in the zip data generator, which means over here we need to create that. Okay, let's just we're not using this anyway, so we can remove this. We don't need this. We need this. Which basically means that here we have range of length of set dot. We can just use this, I guess. Okay, let's try to run this. This should work. Actually, we don't even need anything in matters anywhere, and then we can go to self or capitals. This is where the error is occurring. Let's try to see if this corrects the problem. Oh, it should work. That's the pain of coding, isn't it? Okay, so we go back to the original. So the logic didn't change, right? We got the capital. What about the profiling? Okay, stop. So anyway, okay, the logic is accurate. The logic is accurate. Now, and it returns us data frame. Data frame is date times the index. So this is what we want. Let's truly run the profiling code and see how long it takes for us to run this. You can see, so before we had these operations, we took out all of these dot add assignment values. Right, those are what we targeted. So if you run the reprofiling, right, let's try to run this. Take this and put it over here inside the main file. So let's put this side by side. So this is the previous one. This is the previous implementation, right? We don't have all of these redundant assignments, and this takes the majority of the time. As far as the simulation is concerned, the complete meta info now takes the majority of the time, right? Up to 70%, up from 60%. And also we remove some of the unimportant data generators, right? So for example, here we just completely remove this data frame, right? We're no longer initializing a data frame in the beginning. So instead of having this, we now have a bunch of Python arrays which are more lightweight and easier to work with. So therefore, it's also quicker. And then inside the PNL steps, it's not taking 5% of our time anymore. Right? We're only taking 2.5% because all you're doing is operations. This is order one. It takes a constant amount of time for us to do. This has to do with how fast Python can access the values that we need. Right? This operation is .pen is also very cheap. You can see it takes like less than 0.1% of the time. So that's very cheap to do. And so on and so forth. And we no longer have this commutations where we assign portfolio ef.add thing anymore. Right? We just keep the state inside an array. And then we construct a data frame at the end, which takes basically about 1.5% of our time. Which basically takes about 3 to 4% of our time. And the result is the same. So that's great for us. And we can just remove this profiling because we know that our code is more efficient and also accurate. So now the question is then, how fast does it run? And also whether it's accurate on the other three. I believe we don't need to change because all we did was work with the code inside this utility function. We don't need to change anything. So let's just go back to this and see how long it takes for us to run this three alpha classes, after which we would have completed the entirety of the course. By the way, if you are sick of getting the warning statements, you can just run this. It says for all the warnings, ignore and then run the script. So you will no longer be receiving all of these warning statements, like runtime warning, things like that, which warnings are such suggestions, right? Don't quote me on that. Now you can see our code, just slightly faster. Logic is exactly the same for all three, but compared to the previous version, it just runs about 2 to 3 seconds faster on average, and which is not nothing. If you're running like thousands of this or millions of this backtest, then I guess it's useful. Again, we're not. Now there are perhaps more optimizations that you can perform, but as you can see that at this stage, your code is really fairly efficient, and you're going to face more and more challenges to cutting down the time. I know this is the law of diminishing returns. For example, if you're thirsty in a desert and someone gives you a cup of water, and the cup of water is very valuable, and you're going to have significant amounts of utility derived from that, you're going to be very happy. And gives you a second cup of water, and okay, I guess this is good to have, and you keep drinking. And then it keeps giving you more cups of water, and at some point it's like, well, you don't need water anymore. So every time you keep trying to push, you're going to get diminishing returns, and at some point, well, the time spent on optimizing is just not worth the speed up. So this is where we're going to stop, right? We've built quite a fairly sophisticated backtesting module, okay? The code is fairly clean, right? So it allows us, we've played around with different kinds of strategies, and you can see we don't need to code a lot. For example, if you want to test out a trend following strategy, all you need is about 30 lines of code, and everything else is taken care of by this wonderful utility file. We didn't in fact change the code for this portfolio class to be compatible with the new utility file, because remember, this portfolio is also extending alpha class. So for instance, in this case, we should be obtaining numpy arrays or append series here instead of dictionaries, and we shouldn't have to. And the second return value is we don't need it at all. So this portfolio, this alphas of alphas, no longer works because we've changed the utility base class. But we're not going to go into the implementation of that. We're going to leave that as a homework for the readers to try. It's not that difficult. So I think this has been a good lecture. I hope that you guys have managed to learn a little bit about programming, and together with a little bit about systematic or quantitative testing of hypotheses in markets. And we're going to keep upping the level of sophistication in the 2000 and 3000 and perhaps even the 4,000 classes. So I hope to see you inside those lectures.